Hello children, welcome to my channel. Today in this video, we are going to learn about the concept of mutually exclusive and exhaustive events. We also study how to find probability of an event. So let us start. Mutually exclusive events. Two events E and F of the same sample space are said to be mutually exclusive if E intersection F is equal to phi. That is, the sets representing events E and F are disjoint sets. Let us consider a random experiment of throwing a die once. Then sample space will be S is equal to 1, 2, 3, 4, 5 and 6. Let us consider an event getting an odd number. Then E will be 1, 3, 5 and F is equal to getting an even number, that is 2, 4 and 6, and G equal to getting a number multiple of 3. Multiple of 3 are here only 3 and 6. Clearly, what is E intersection F? You can see there is no number is common between E and F. So, E intersection F is equal to phi. So, you can say E and F are mutually exclusive. But E intersection G or F intersection G are not equal to phi. So, E and G and F and G are not mutually exclusive events. Next is exhaustive events. We will try to understand the concept of exhaustive events by taking an example of a random experiment of tossing a coin thrice or 3 coins tossed simultaneously. Then sample space will be this. Let us take 3 events E1, E2, E3. E1 is at the most one head. E1 at the most one head means not more than one head. So you can take cases of no head. No head means that is TTT, no head. And cases of one head only, that is HTT, THT, TTH. E2 is the event not more than one tail. Not more than one tail means no tail and one tail. So, no tail means head, 3 heads having no tail, and one tail. One tail means THH, HTH, HHT. E3 is at least 2 tails, means 2 tails and 3 tails. So, cases of 2 tails are HTT, THT, TTH and 3 tails TTT. Now, E1 union E2 union E3. This is equal to, so these are the elements of E1 union E2 union E3. You can verify this is equal to sample space S. So we can say events E1, E2, E3 are said to form a system of exhaustive events. In general, if E1, E2, E3 and so on En are events of same sample space S, and also E1 union E2 union E3 and so on union En is equal to sample space S itself, then the events E1, E2 and so on En are said to form a system of exhaustive events. Next is mutually exclusive and exhaustive events. Let S be a sample space associated with a random experiment, and E1, E2, E3 and so on En are events of S. Then events E1, E2, E3 and so on En are said to form a system of mutually exclusive and exhaustive events if condition number 1, EI intersection EJ equal to phi for I not equal to j. That is, E1, E2 and so on En are pairwise disjoint. What is the meaning of pairwise disjoint? It means E1 intersection E2 is equal to phi, E2 intersection E3 is equal to phi, and so on. En minus 1 intersection En is equal to phi. Condition number 2. E1 union E2 union E3 and so on union En is equal to the sample space. If these two conditions are satisfied, then events E1, E2 and so on En are said to form a system of mutually exclusive and exhaustive events. Let us consider a random experiment of tossing a coin thrice, or 3 coins are tossed simultaneously. Then sample space will be this. Let E1 is the event getting no heads. No heads means only tails, so there will be only one element, that is T, T, T. E2 is the event getting exactly one head. So one head means two tails, so there will be these three elements in E2. And E3 is the event getting at least two heads. At least two heads means two heads and three heads. So I have taken the cases of two heads and three heads. Now we have to verify the two conditions of mutually exclusive and exhaustive events. So first is E1, E2, E3 must be pairwise disjoint. So let us find E1 intersection E2. E1 intersection E2, this is phi, nothing is common. Now, what is E2 intersection E3? This is also equal to phi, E2 intersection E3. No element is common between these two, so this is also phi. And E3 intersection E1, this is also equal to phi, E3 intersection E1. Nothing is common between these two. So first condition is satisfies, that is E1, E2, E3 are pairwise disjoint. Now what about the second condition? Second condition is E1 union E2 union E3, this must be equal to S. E1 union E2 union E3, this is equal to combination of these three events, and clearly you can compare that this is equal to a sample space S. So both the conditions of mutually exclusive and exhaustive events are satisfied. So we can say E1, E2, E3 are said to form mutually exclusive and exhaustive events. Next is probability of an event. Let S be a sample space and E is an event of S, then probability of event is given by PE is equal to number of outcomes favorable to E divided by total number of possible outcomes. This is also equal to number of elements in E divided by number of elements in S. So by this formula you can calculate probability of an event. Probability of impossible event P phi, number of elements in E are 0. So probability of impossible event is 0. Probability of sure event PS, this is equal to 1 because PS means the event S itself. So number of elements in S divided by number of elements in S. So this is equal to 1. So therefore probability of an event is always lies between 0 and 1. This is a very important result we have to